In this video, I'm going to show you how you can take a snapshot of the order book for any pair currently trading on Binance or Binance US, how you can download that data using the Binance free API without needing to sign up or log in with any kind of API key. And towards the end of the video, we'll do some analysis on the order book, and we'll be looking at Orderbook Imbalances. So for example here, if I take the price out by 0.5%, we can see that we have a much higher volume of asks than bids. And this can be an important indicator that I know a lot of people like to include in their algorithms. So I'll be going through how to download the data, how to clean it up, and how we might go about inspecting different metrics like the order book imbalance to derive an edge. So let's dig into Python here and we'll get going. So I've got a Jupyter notebook open here. We only really need two libraries for this. We need requests, and that's just going to handle asking Binance for the data basically. This is going to handle interacting with the API, so you definitely need that. And then I'll also be using pandas here. So pandas is going to allow us to do analysis on the bids and asks once we've actually downloaded them. I'm sure many of you will be familiar with pandas, and that's why it's a great platform to do any data analysis. The next thing we'll need here, of course, is the API URL. Now, you can find this in the Binance documentation. I'll leave a link in the description. But generally, you'll just want to go to the top of the documentation, wherever that is. Grab the base URL here, so https:/api.binance.com. If you trade on Binance.us or you want to find info for Binance.us, all you have to do is just change the URL. So I'm going to paste it in as Binance.com, but if you want Binance.us or Binance.jp, I believe all you have to do is that. We'll test it out at the end here, but I've tested it for US and it definitely works. For now, we'll get data from .com. That's the base URL there. On top of that, we'll need to inform the API that we want order book information. So if you go down to market data endpoints, order book, you'll see this is the path we have to ask for. So just go back here, paste that on the end of our URL, and there we go. We'll also want to define a couple of other things in here. So we'll provide some parameters here. So params is equal to a dictionary. And if we go to the endpoint here, you can see there are two different parameters we can give. So we can give the symbol pair. Obviously, we need to give that. Otherwise, Binance doesn't know which one to give us. And we also need to give it the limit. This limit value is how many price levels from the mid price should it give you on either side. So if I go over here to this Solana trading pair here, we go down to the most granular data. Each one of these is one price level. So this is one price level, this is another on the ask side, and this is another 3 on the bid size. So if I had a limit of 10, it would grab me 10 asks and 10 bids and return to me that information for the most granular option that Binance offers. That's what that number does there. So by default is 100. The maximum you can ask for is 5,000, which will give you quite a large range of data. So let's set up those two parameters. So I'll go back to my notebook here. So we have a symbol. And symbol, well, I'll just leave as Solana USDT for now. I picked Solana rather than Bitcoin because the order book's going to be smaller for Solana, so it's easier to analyze. I'll also pick a limit in here of, let's say, 100. We'll just leave it as default for now while we're testing. We can always crank that up later on. So we'll run that. That's kind of our configuration out the way. We've imported all our libraries. Now, in order to get the raw order book information, it's actually so easy. So you just do requests.get here. So data equals request.get. Pass in the URL that we had up here. So this points to order book depth. And then we set the parameters. So just params equals params. So we set the parameters for the request equal to our dictionary here. We'll convert it to JSON here, so .json. And then we'll just print out the results of data to see what that looks like. So you can see that this is a dictionary here. So we have an update ID. So this tells you how many order book updates there have been. This is only really useful if you're trying to maintain an order book in real time, so you need to keep track of the updates. We're not going to bother with that. And then we have the bids here, and if you scroll down far enough, we'll also have the asks. So basically, we have the bids key here, and the value for that is a list of lists. And inside each one of these lists, the first entry here is the price level, and the second entry is the quantity available at that level. So at this price here, there is 533.24 Solana available, or since this is on the bid side, there is 533.24 Solana ready to buy if the price would fall to that price. You'll notice all the values are strings here. That's actually quite helpful for us because it means that floating point errors don't get in the way of our calculations. We can keep the price level exact if we want to. And it means there's no data loss from Binance to our machine if we're using a slightly different floating point implementation. So this is our order book information. It's everything we asked for, but it's not in a massively useful format. You'll struggle to do much data analysis with this without writing some custom tools to parse everything. And so that's what we're going to do in the next part of this video. We're going to tease out the information from here and show how we can use it to calculate order book imbalances. Now, the way I chose to do that is I'm going to create a new data frame for the bids and for the asks. So they're going to live in their separate data frames. We can join them together if we wanted to display that, but it's going to be much easier if we keep them separate. So let's just put this straight into a data frame here. So pd.dataframe. We'll grab data and bids, and we'll see what that looks like. So it's looking reasonable. We need to change the column names here. So we'll say columns is equal to price and quantity. See what that looks like. Okay, looking a little bit better here. If we print out the D types though, I suspect they'll still be strings. So this is the bid levels. Let's print out the D types here. So bid level dot D types. We can see these are both objects. If we're going to do any analysis on them, we really need them to be numbers. So we'll have to convert them to floats here. So we should just be able to add a dtype attribute in here. So data type is equal to float. So rather than a string saying 32.74, it's going to be actually a number, 32.74. Just makes our life easier if we want to do any kind of analysis on this later on, which we definitely do. I'm also just going to add one extra column in here. So I'll do bid level. I'll call it side, and that's going to be equal to bid. The reason why I'm doing that here is so that when we join the bid and ask data frames together, when we display them, we'll be able to distinguish the bids from the asks. Now we just need to do the exact same thing here for the asks. So I'm just going to copy and paste that. And we'll have ask level is equal to pd.dataframe. We'll take in the asks. This is all going to be the same. And we'll want the ask level and the ask level. Here we go. Run that, and we should be good. Do a quick check here to make sure these are different. We wouldn't want them to get confused. So the lowest ask here should be bigger than the highest bid, 32.87, 32.88. So that's looking good to me here. We can quickly show these in a single data frame, just if we want to get an idea for what the order book looks like, to get more of a visual representation. So we can just do print bd.concat, and then we'll pass in the bid levels and the ask levels. Let's see what that looks like. Bid levels is not defined. Bid levels. Okay, let's try that out. There we go. Everything's a bit out of order here. So we'll enforce the price to be in descending order here. So sort values on price, ascending equals false. And then if you want to see the full thing, you can do a .to_string here. So that'll print the full order book out for us. We can see all of the various asks here and the quantity available at that level. And we should also be able to see the crossover point over here where we go from ask to bid. And we can check that indeed the ask is greater than the bid. Just to do a bit of sanity checking here. Of course, this is going to be pretty much immediately out of alignment with this one here, which is why if you're using these order book snapshots, especially on a shorter time period, you want to request this over and over and over again to calculate your imbalances. Speaking of imbalances, let's go ahead and calculate those. So we'll define a threshold here, threshold, and we'll define it as a decimal. So I'm going to say 0.01. That's going to indicate a 1% movement in the price. We'll find the total bids available in that range and the total asks available in that range. Exactly like the chart we had before, this depth chart. So if you go 1% out, if I zoom in a little bit, we're basically going to calculate these numbers on the right and left of the graph there, if you can see them, but much more accurately than we can do by eye here, and then we can calculate the difference between them. So our threshold is going to be 1%, and then we need the price, obviously, so we can go 1% above or below. So I'm going to use the mid price here. The mid price is just halfway between the best bid and ask. I'm going to be using that to proxy the price here. It should be a good enough estimation of what the price is at the time of trading. To get that, all you need to do is you need to take the highest bid, so the maximum of the bid levels, and the minimum of the ask, so the min ask level, and then just divide the whole thing by 2. Let's print that out just to make sure it looks reasonable. Always a good thing to do here. So mid price 32.875, which the price has moved a little bit, as you can see here, but that looks overall pretty reasonable to me. The next thing I'm going to do here is check that we've actually requested enough data. So we only requested 100 levels here. And if you compare it to the value from the exchange, you can see that gets us maybe $1 of price difference up and down. So we're going 100 different values out, and that gives us roughly $1 of price difference. A 1% movement in price would be about 30 cents, given that Solana's $33 right now. And therefore, in this instance, we know that we've got enough order book data here to cover a 1% movement up and down. But we want to make really sure using code so that if we're trading a much more granular pair, something like Bitcoin, we want to make sure that we have enough order book data to actually calculate this information and that we're not being fooled. So the way I'm going to ensure that is I'm just going to use an assert statement here. So we'll check that we've got enough data, and if we don't have enough data, then we'll throw an error. That's essentially what this assert will do here. So first we'll check the amount of asks that we've got. So we'll check that the maximum of the ask levels here is greater than 1 plus the threshold multiplied by the mid price. So whatever 1% above the mid price is right now, so our threshold, so 1.01 times the mid price, we want to make sure that our price data at least covers that area, and that way we can be sure that we've got enough market depth. So I'll add an error here if something goes wrong, so insufficient market depth. And then I'll do the same thing here below, just with the bid levels. Bid levels, and we want to go below here, so it's 1 minus. And again, if we don't have the appropriate amount of information below the mid price, we again want to throw an error. We don't want to feed ourselves dodgy indicator values that's going to mess with our calculations. So we got an error there. That's because instead of the max, this should be the min. If I run that again, there we go. So just maybe a visual representation of this. We want to make sure that our order book data is at least 1% higher than this number. So in our case, this would be like up here to 33.3 or 33.4. So we want to check that the maximum of our ask data here is greater than 33.4 and that the minimum of our bid data is less than about 32.7 to ensure that our data is nice and clean and that we've got everything we need to calculate. Once that's done, we can go ahead and just throw up a few print statements here. So we can print our different price thresholds here. So print the ask threshold. So the threshold on the upper side, that's just going to be 1 plus the threshold multiplied by the mid price. We'll print out the mid price here, so the mid price. And we'll also print out the bid threshold. So the bid threshold. Mid price is going to look like that. And the bid threshold is going to be 1 minus. So if we print this whole thing out, we're basically looking at data between 33.2 and 32.54. Again, the price has moved here. As you can see, we're now on about $33. So what I can do is I can just do sell run all. That'll give me new and updated information here. We can also print out our maximum ask and our minimum bid here. So print max ask here. Just going to be the maximum of the ask levels dot price. And we'll do the same for the minimum bid. Again, this is just another triple check here to make sure that we've got all of the correct information in our order book. Super, super important. You don't want to be trading off indicators that aren't calculated correctly. So we can see here that our order book that we've downloaded covers price data from $34 to $32.01. And the spread of price that we're examining here fits well within that threshold. Now we're in a position where we can calculate our order book imbalance here. So we can see how skewed the order book is and come up with some probability estimates for how likely the price is to move in a given direction over the next X amount of time. Or how many buys and sell orders there are there waiting, providing resistance against any possible price movements. So we'll print the ask volume here. So the ask volume, well, what's that going to be? It's going to be the sum of all the quantities. So ask levels dot quantity. But we only want the quantities where the ask price is within this threshold. So between the mid price and this ask threshold here. So we want to index into this series where the ask levels dot price is less than 1 plus the threshold multiplied by the mid price, and then we can just sum this whole thing here. Sum. That's a bit of a long expression there. The loading bar's starting to come in, but I'll just copy and paste that below, and we'll do the same thing for the bid volume here. So the bid volume is going to be the bid levels, and minus the threshold in here. And that should work. That doesn't look quite right to me here. Let's have a little look. Yeah, I got this the wrong way around here. That should be a greater than sign because, again, we only want bids between this threshold and this amount. So we want to be greater than the threshold, but less than the mid price. Run that again. That is quite a large delta there. So you can see there's a difference of almost, 33,000 Solana. So let's run the whole thing again. And there we go. It looks like such a large gap was just an anomaly. That seems to be working fine. And then finally, we just want the delta, which is the difference between these two. So I'll just assign these two variables here. So like ask vol is going to be equal to this, and then bid vol is going to be equal to this. That way I don't have to keep copying and pasting the whole thing. So we'll print the ask volume. just the ask vol, and we'll do the same thing with the bid volume. And then we'll finally print the difference between them. So print Orderbook Imbalance. And that's just going to be the difference between the bid and the ask. So it's going to be the bid vol minus the ask vol. Completely arbitrary, of course, which way you minus them from each other. Just make sure that you do it consistently. I use this methodology because if the bid volume's significantly higher than the ask volume, that's a traditionally bullish indicator, and so therefore I want the value to be positive. Whereas if the ask volume's super high, it means there's lots of sell walls there, which is bearish, and therefore I want this value to be negative. So that's why I did it that way. We can just run this as many times as we want here, and we'll get all the new values. It should only take maybe a second or two in order to run these. In terms of how frequently you can request this, so say you put this into a script. So I've got one over here, this example.py. If I do Python example.py here, I've got this automatically calculating all these indicators for me, like you would do in your trading system. How frequently can we do that? Well, if you go to the Binance API again here, in this help forum here, we can see there's a limit of 1200 wait every minute for the Binance API. And each request has a different amount of wait associated with it. So if we go to our order book endpoint, we can see that requesting 100 price levels each way, so for bid and ask, only has a wait of 1. So we could do that 1200 times a minute if we wanted to, which is definitely more than enough. If we need significantly more price levels though, so say we need 5,000 price levels, in that case, that's going to use a wait of 50, which means that you're only going to be able to do this about 20 times a minute or once every 3 seconds, which depending on your trading needs, that may be more than enough. If it's not, you'll have to go real time, which is significantly more complicated and involves WebSockets. For certain pairs, like Bitcoin, 5,000 levels won't actually get you that far. So I'll just show an example here. So instead of getting 100 levels for Solana here, let's just get 5,000 and we'll see how far that takes us. So we'll just keep progressively running our cells here. I'll just run them all, in fact. So that's going to scrape our data. And let's see how far we can push this threshold here without getting beyond the reach of our data. So 1% price movement, we already established that's perfectly fine. If we look at our range down here, we can see that the ask goes from 51 cents all the way up to $95.69, which is quite the range. This is also mislabeled wrong here. This should be the minimum bid. Just fix that. So for Solana here, the order book's got considerably fewer levels in it, which means that we can basically request as large a price movement as we want. We could request a 90% movement here, and I'm sure that would be fine. So a 90% movement. Our asserts ran through. Our ask threshold is now running from 62.66 all the way down to $3. And we could look at the order imbalance for such a large range, although it's not massively meaningful on that scale. But if I go to something like Bitcoin here, so BTC USDT, you'll see that we get a considerably lesser range of data just because there are many more price levels in place for Bitcoin. So we'll just run all the cells again and we'll see what happens. My prediction here is that our assert failed, so yes, we don't have nearly enough volume data to examine the order balance for a 90% move in Bitcoin, which is of course improbable over any short period of time. Instead, we can look at a 1% move here and see what that looks like. It's looking like we don't have space even for that, so let's look at a 0.1% move. It's looking like our mid price has been improperly calculated here. Let's investigate that, why shan't we? Aha, a glorious spelling error has got us there. The variable was still defined from when we mistyped this before, so this is ask levels, and this is ask levels. So let's run the whole thing again. Now we're getting proper values. And so now let's take a look at a 1% value here. So 1%. The assert runs this time, we've got enough data. A 1% movement takes us from 21,067 down to 20,649. Our min, bid, and ask here are more than sufficient to cover a 1% move. Well, just enough. We've got about $100 leeway either side, so our value is going to be accurate. Calculate our ask and bid volume here, and therefore the delta, which is minus 337 Bitcoin. So I hope you enjoyed the video and you learned about how to take order book snapshots from Binance, and that you're now comfortable using the API, organizing and cleaning the data, fitting it into Panda's data frames, so that you can do all manner of calculations with it to give you an edge. If you enjoyed the tutorial, give the video a like, and I'll see you in the next one.